Hello everyone. In the last lecture, I have discussed the basic Swiss capacitor cell. Today, I will discuss how the basic Swiss capacitor cell can produce the different positive and negative voltage level. So, basic Swiss capacitor cell, that is already I told in the last lecture. So there is a source, there is a diode, and there is a Swiss, and this is capacitor, and similarly this is another Swiss. So, and you see this basic cell is available in the literature. You can find this basic cell in IEEE journals like Professor Ibrahim Babai journal. You can find it. So like that, but you can search. It is a very commonly structure is available in the literature. So this is the capacitor S1, S2, and here in the last class, in the last lecture, I connected a resistance here. So I connected HVDC here. HVDC means there is a two switches. So this is called leg 1 and another two switches, that is leg 2. Okay, and in between there is a load is connected. Let's say I am considering a resistive load. So this switches has an antiparallel diode. If I connect a inductor here, the negative kind of flows through the antiparallel diode. So for a simplicity, I am considering resistance only. And this switch is SH1, SH2, and SH3, and SH4. So this circuit, and this is diode D. This circuit has a two part. First part is called level generation, because it will produce the different voltage level. And this part is called polarity generation, because in this part only this across the load, the different positive and negative levels it will generate. It will synthesize. So what is the switching table? Switching table. So switching table means we need to find out which switch I need to turn on such that different voltage level can be realized across the load. So here we can see that there is a DC source and one capacitor, and capacitor is charged, can be charged to VDC only. So highest voltage can produce 2 VDC. So this is actually 5 level SCMLI, because highest voltage is 2V. So different voltage level is plus 2 VDC, then plus VDC, then plus 0. 0 means it is positive half cycle 0, and minus 0, minus VDC, and minus 2 VDC. So what is the actually different switch we need to turn on such that these voltage levels can be realized across the load terminals. So let's say I am considering 2 VDC. If I want to produce 2 VDC here, and this is my positive terminal and this is negative terminal. So when this S1 will be turned on, this voltage source is connected in series with this capacitor, and this switch is turned on and this switch is turned on. So like this current can flow. So what is the voltage across this load? R is nothing but this voltage plus capacitor voltage. So it is coming to VDC. So what other switches are turned on? S1, then obviously SH1 and SH4. And at that condition, what is the state of capacitor? Capacitor actually discharging the energy towards the load. So capacitor state actually it is discharging. When plus VDC, I need to realize I can charge the capacitor because S2 is turned on. So capacitor will be charged, and at that time I can turn on these two switches. So obviously this capacitor will get charged, as well as the plus VDC voltage level can be realized. So here I need to turn on S2 because this switch is on, means this capacitor will enter into charging state, and here SH1 and SH4. So at that condition, capacitor will get charged condition. At the same time, the level will be realized. So this is actually charging state. Now plus 0 means positive half cycle 0 level. We can realize. Okay, so at that condition, capacitor can enter into charging state. But what happen if I enter the capacitor in charging state? There are some losses will happen in the ESR or equivalent series resistance of the capacitor. So there are some losses will happen. So to avoid that losses, only we will realize the voltage here 0 voltage. So if I do turn on these two switches, SH1, SH2, the load will get shorted here, so 0 voltage can be realized. Similarly, negative 0 level we can realize from these two switches, that is SH3 and SH4. Minus VDC voltage level can be realized same as positive voltage levels. Positive VDC voltage level. Here we need to, instead of these two switches, we need to turn on these two switches, so that polarity will get changed across the load. So here I need to turn on S2. These two switches I need to turn on. So SH2 and SH3. Now plus 0 and minus 0, this voltage level capacitor is in floating condition because these are off condition. So it is just a floating state. So that is we can represent like this. Similarly, in this state, capacitor is entered into charging state because S2 is turned on and negative voltage level is realized. Minus 2 VDC can be realized when S1 is turned on. So like this, it is connected in series and SH2 is connected, SH3 is connected. So we can find out S2 is H2 and SH3, and capacitor will get pictures. So this is actually switching state and capacitor state table that we need to understand to generate the different voltage level across the load terminals. In the next lectures, I will tell how the capacitor voltages get balanced here without any auxiliary circuit. It is automatically get balanced. We need to balance this capacitor voltage, and it is happened automatically because this does not require any auxiliary circuit. That is the one of the major benefit of Swiss capacitor multi-level inverter. Thank you for listening.